Hello everyone, welcome to this session on synthesis of mechanisms for function generation using analytical approach. In the previous session, we came to a conclusion that in order to synthesize a 4-bar mechanism, we need to use Chebyshev spacing and Freudenstein equation together. So the purpose of Chebyshev spacing will be to calculate 3 accuracy points for 3 position synthesis of the mechanism, and the purpose of Freudenstein equation will be to solve for the dimensions of the links in the mechanism, which are L1, L2, L3 and L4. So let's take a numerical problem and let us solve this numerical problem using the Freudenstein equation. So let me read out the numerical problem for you. So it is asked to synthesize a 4-bar mechanism in which the motion of the input and the output links are governed by a function y equal to x to the power 1.5, where x lies in the range of 1 to 4. We are assuming that the theta rotation of input link, it has to vary from 30 degree to 120 degree, and similarly the phi, the rotation of output link, it has to vary from 60 degree to 130 degree. So the range of travel for the input link, that is given as 30 degree to 120 degree, and the range of travel for the output link, it is given as 60 degree to 130 degree. And the length of the fixed link, that is provided as 30 m. So here I am using an Excel sheet, so this will be basically easier for all our calculations. So let us see the different steps used to solve this particular numerical problem. So obviously the first step will be to calculate the Chebyshev precision points. So we know that the Chebyshev spacing of precision point can be calculated by this expression: xj equal to xf plus xi divided by 2 minus xf minus xi divided by 2 cos of 2j minus 1 pi divided by 2n, where j is equal to 1, 2, 3. So obviously we are limiting ourselves only to 3 position synthesis. So we will take j as 1, 2, 3. Now let me write down what are the given parameters which we have, right? So n is obviously given as 3, right? In the above equation we can take this n as 3 because we are taking 3 precision points. Xi, the initial value of x that is given in the question. So we can see here that x is lying in the range of 1 to 4. So the initial value of x is 1. Now the final value of x is 4. That is also provided in the question, right? Now from here, the initial and final values of x, we can actually calculate the initial and final values of phi. So we know that this expression is y equal to x to the power 1.5. It is already given to us. So yi initial value we can take as 1, and yf simply x to the power 1.5, that is 4 to the power 1.5, that will be taken as 8. Now all these calculations you can simply see, right? Once I have written down the given values, I am simply, right, using the cells of those particular values to calculate the remaining values, that is yi and yf. For example, to calculate yi, I have taken this cell C11. So you can see the expression here. This will be simply C11 to the power 1.5. Similarly, yf, I have taken this cell which is C12, right? So you can see the expression here. So this will be basically C1 to the power 1.5, right? So all the formulas in the particular cell you can see basically in this top bar, the formula bar, right? Now let's move to the calculation of this Chebyshev precision point. So I have written down 3 precision points as x1, x2, x3. Now let us see how can we calculate x1. So to calculate x1, what we are doing, we are taking this value xi plus xf by 2. So you can see here that this will be basically c12 plus c11 divided by 2. So this is nothing, right? It's very easy to guess here that these values, they are not going to change, right, for calculation of precision points. So just to fix these values, I have used a dollar sign here. So we can substitute something like this, that is $12 plus $11 divided by 2. Then you have minus of again this cell $12 minus this one 11 divided by 2, then multiplied by cos of, right, then I am taking this angle 2j. So obviously this is the first precision point, so we have taken 1, then after that -1, right? So this is your -1, then multiplied by pi by 2n. So you can see here, this is my pi divided by 2 multiplied by 3, right? So this expression we can write down in this formula bar and for this particular cell, and we can calculate the value of x1. Now once you have calculated the value of x1, you can take y1. y1 is nothing, this is this cell b14, right? So you can see here b14 raised to the power 1.5. So y1 will always be governed by this equation, y equal to x to the power 1.5, right? Now similarly we can calculate x2 and x3, right? And we can, once we have the values of x2, x3, we can calculate y2 and y3, right? Now once you have the values of x and y, then what you do, the next step is simply to calculate the corresponding values of theta and phi for these three precision points. Now again we can see here the range of travel for theta and phi that is given, right? So theta I, the initial angle, you can take as 30 degree, right? So you can see here the rotation of input length, it is limited in this range 30 degree to 120 degree. So theta I you take as 30, theta f is also given as 120 degree. Now while making these calculations in Excel, just make sure that here basically you need to convert all these angles into radians, right? Because Excel usually reads the values in radians. So here now you can see that 30 degree it will be taken as 0.5236. So to convert it into radians, you multiply this cell, that is C20, that is 30 multiplied by pi divided by 180. It's very easy. Same you apply to this theta f, that is C21, that is 120 multiplied by pi divided by 180. Now you repeat the same exercise for this phi I and phi f. So obviously the range of travel for the output link that is also provided to us, that is 60 degree to 130 degree. So you put the 60 here in this cell and 130 in this cell, and now you can calculate phi I basically by multiplying this cell value, that is 60 multiplied by pi divided by 180, and you do the same thing for the phi f value. Now once you have the initial values of theta and phi, what is our next step? So as we already know that delta theta, it will be proportional to delta x, right? So we can simply write down one expression. So this expression you can see here, this is theta j minus theta I, right, divided by delta theta. So this is equal to xj minus xi divided by delta x. So now what exactly is this expression? This is simply nothing. You can see here this theta j is the input angle value corresponding to the, right, first, second and third precision point. Theta I is the initial value. Delta theta is the range of travel for the input link. Here again we already know xj is the x value for the first, second and third precision points. Xi is the initial value and delta x is the range of x value, right? So these things we have already calculated here. So delta theta is nothing. This is this cell, that is 120 minus 30, correct? Or if you are taking it radius, so this will be basically this cell, right, minus of this cell. So you can see here this is nothing, this is D21 minus D20. Now similarly delta x is nothing. You have these two values, initial and final values of xi and xf. So this will simply become 4 minus 1, that is 3, correct? So here you can see delta x is 3. Similarly, you calculate delta phi and delta y. So delta phi will be basically this cell, right, that is I21 minus this cell, right? So you can see here delta phi is nothing, this is I21 minus I20, correct? Similarly delta y you can calculate. So see here we have already taken up the values of yi and yf, right? So we have this expression will help us to get the values of yi and yf. So from here delta y is nothing, this is simply 8 minus 1, that is 7. So delta y you can write down 7. Now similar expression, right? So you can see delta theta is proportional to delta x, so delta phi will be proportional to delta y. So the same expression, right, you can write down for the output angle phi as well, right? Now once you have these two expressions, right, let us simplify it. So theta j is nothing, this is equal to theta I plus xj minus I multiplied by delta theta by delta x. Similarly, phi j is nothing. It is equal to phi I plus yj minus yi multiplied by delta phi by delta y. Now, to calculate theta 1, let us go for the expression here. So you can easily see here that theta 1 is nothing, theta I, right, which is this angle, right, D20 cell plus B14 minus C11, right. So what is this B14 and C11? So see here, so it's nothing, that is xj minus xi, right. So xj is here, we are calculating the first precision point. So xj is basically x1, that means this value 1.201, right. So you can see here, this is B14 cell 1.201 minus C11. So what is C11? C11 is the initial value of x. So we already have this C11, right, which is equal to 1. So you can take it 1.201 minus 1 multiplied by C24 divided by C25. So what is this? This is nothing, multiplied by delta theta by delta x. So this is your delta theta, this is your delta x, right? So you can easily write down this expression, correct? Something like this, and you can get the value of theta 1. Now let's have a look at the value of theta 2. So theta 2, it will be also something like this, that is D20. So again, this cell will be a fixed cell, so it's nothing. So here you take D20 plus, then you have B15 minus C11. So where is your B15? B15, you can see that this is nothing, since you are calculating for the second precision point. So B15 is nothing, this is x2 here minus, right, B15 minus xi. So xi, the initial value is obviously 1, right. So let me take you to that expression, right, just to avoid confusion. So here you can see this is B15, that is 2.5 minus C11, that is 1 multiplied by C24 by C25. So again, this expression, right, that is delta theta and delta x, they remain same. So these cell values, they remain same. So you can apply the same concept here to calculate theta 2. Now when you go for the third precision point, the remaining values in this expression, if you see, they remain same. The only change is that this value is going to change, the value of x. Now this xj, it will be taken as basically this value 3.799. Now once you have calculated the values of theta 1, theta 2, theta 3, the same exercise you repeat it and you calculate the values of phi 1, phi 2, phi 3. Now phi 1 is nothing, so let me show you one example. So phi 1 is phi I, that is initial value of phi. So this is nothing, this is this value 60 degree. If you take it in radians, so it will be 1.047 plus, right, plus then you have yj minus yi. Now again you will take the yj value, that is you are calculating the first precision point. So yj will be taken as y1. So where is your y1? Let's go there, right. So this is the value of y1. So 1.31 minus, right, yi. So that is the initial value of y, this which is equal to 1. So 1.31 minus 1 multiplied by, right, delta phi divided by delta y. So where is your delta phi? So this is your delta y, phi 1.221 divided by delta y, which is 7. So it's a very simple expression which you can write down here, right. So this is how you can calculate phi 1. Now if you repeat the same exercise, you can calculate phi 2 and phi 3. Once you have calculated the values of theta 1, theta 2, theta 3 and the corresponding values phi 1, phi 2, phi 3, then the next step is to simply apply the Freudenstein equation. So as we know, the Freudenstein equation is simply given by k1 cos phi plus k2 cos theta plus k3 equal to cos theta minus phi. So just a small correction here. In the previous session, right, when we discussed the Freudenstein equation, we said that here this minus L1 by L4 term we are replacing by k2. So instead of a negative sign here, you have to simply put a positive sign. So this is just a small correction in the Freudenstein equation that we discussed in the last session. Now let's go back to the calculation part. So once you have this equation, now here what we are trying to do, we are trying to actually solve this particular relation, right, by using the solver add-in in the Microsoft Excel. Now, how to use this solver add-in to solve this equation? Let us see that. Here, first of all, what we are going to do, we will simply note down the three values of theta and phi as it is. So you can see here that theta and phi, I have simply taken theta equal to this B29 cell, then the next value, that is theta 2, equal to this cell, and then the next value theta 3 equal to this cell. The same thing I have repeated for phi 1, phi 2 and phi 3. Now we have written this theta phi values collectively at a single junction so that it becomes convenient for us to calculate this coefficient of variables. Now, as we say that if we wish to solve this particular equation, there are three variables k1, k2 and k3 which we have to find out. Now the coefficient for this k1, k2, k3, right, we are going to write down this thing into this tabular form. Now here we will make basically three rows, equation 1, equation 2, equation 3, and then we are making three columns corresponding to three coefficient of variables, right? So here you can see that this is going to represent the coefficient of the variable k1. This is going to represent the coefficient of variable k2. This is going to represent the coefficient of variable k3. Now the same thing we can apply to equation 2 and equation 3 as well. So what are these equation 2 and 3? These are simply obtained by substituting theta 2, right? That means this one, and phi 2. And here this equation 3 we are going to obtain by substituting theta 3 and phi 3. So let me pick up a cell just to demonstrate this point. So here you can see that the coefficient for this variable k1 is cos phi. So we are taking this thing equal to, right, cos of, you can see this cell M12, that means cos of 1.10237. Now similarly, if you take up this cell, so the coefficient for variable k2 is cos theta. So this is your cos theta basically. Now here you can see that we are simply taking this cell equal to cos of this angle L12, that is 0.62882, right? Finally, obviously we know the coefficient for variable k3 is 1. Now same thing we will generalize to the theta 2, phi 2 and theta 3, phi 3 equations. Now let us make another table, right? In this table, let us prepare again three rows, equation 1, 2, 3 and two columns. One will represent the values on the left hand side of this expression. So this is k1 cos phi plus k2 cos theta plus k3, and one will represent the values on the right hand side of this expression. So you can see on the right hand side, right, if initially let us assume that these values, they are not known to us. Let me make these values as 0. Let me delete them. So initially these values are not known to us. So obviously this will, LHS will become 0 for all the three equations. Now on the other side, if you check the right hand side, so for the first expression, that means when we are using theta 1 phi 1, the right hand side will be simply equal to cos theta 1 minus phi 1. So if we click this cell, we can check it out here. This is equal to cos, then theta 1 minus phi 1, that is this cell L12 minus this cell M12. Now the same thing you can do it for the theta 2, phi 2 and theta 3, phi 3 values. Let us do one thing. If you just click here, I have used a formula which is simply sum product P12 to R12 comma Q8 to S8. So what exactly is this formula? This is nothing. This is simply multiplying the variables with their coefficient and calculating basically the value of this expression k1 cos phi plus k2 cos theta plus k3, right? So to take the sum product, what we do, first we simply write down sum product, then create a bracket. Then what you do, then you simply select the coefficient. That means here you can see that this coefficient what we have selected in this equation is P12 to R12. So you can see that these are the coefficients P12 till R12. Similarly, comma, right, you have to write down Q8 to S8. That means the variables themselves. So this is the variable Q8. You can see this cell is Q8, then you have R8, then you have S8. So it will simply multiply the individual cells and then it will sum up the multiplications. That's it, right? So now once you have, obviously here you will have the left hand side 0 0 0, because right now we don't have any value into these cells. Now on the right hand side, this is very easy. On the right hand side you have this cos theta 1 minus phi 1, cos theta 2 minus phi 2, and cos theta 3 minus phi 3. So this part we already discussed. Now to solve this equation, right, you simply go to this data section. Under this data section you have this tab solver. If you are not able to locate this tab solver in your Excel sheet, what you can do, you can simply go to this file and then you go to options, and then finally you go to this add-ins. Here in this add-in you can simply check for this Excel add-in, then you simply press go. From here you can actually search for the solver add-in and you can add it to your Excel sheet. Once you have done that, let us go back. Let us see how can we solve actually this equation using this solver tab. Now here what you do, see, the thing is that our simple objective is to make the left hand side of this equation equal to the right hand side. So we will go to this, we will click on solver. On the solver you will select this particular cell. So this particular cell, you can see it is nothing, it's $P$17. So this is P17 cell. Now here if you go to this set objective to, right, now we know that this left hand side, it has to be made equal to the right hand side. So you can set the objective to a value of 0.88996. So you simply enter this value here. But at the same time you have to keep in mind we have two other expressions where we have to equate the left hand side to the right hand side. So now these two other expressions, right, you can take to the constraint part, right? So now what you can do here, first you go to this cell, and obviously we know that we are trying to achieve this objective by changing which variable cells. So you are basically changing these variable cells Q8. So let me click on this cell. So Q8 to S8, right? So you simply select those cells, they will be selected automatically here. After that, what you do, after that you come to this subject to constraint, right? Now subject to constraint, let me just delete it for some time just to show you how it can be done. Now in subject to constraint, what you do, you click on add, right, and then you have the cell reference. So you pick up this cell, the cell that corresponds to equation 2, and you know that this is the left hand side of this equation 2. Now this should be equal to the right hand side. So the right hand side is given by this one. Now you add it. After that you repeat the same thing for the cells corresponding to equation 3. So again you select this cell. Now this cell, it has to be equal to which one? The right hand cell, that means this one. Now once this is done, you simply add it. Now after addition you simply click on cancel. Now you can see here your objective, the variable cells in the constraints, they are all clear. Now here we have two options. If you want to make these variables non-negative, you can check this. If you want to make these variables, right, both a combination of negative and positive values, then you can uncheck this. So in this case I am simply unchecking it. Now here, since it's a simple set of linear equations, so we will use the simplex LP, that is simplex linear programming approach, right, to solve this particular equation. So once you select it, right, and all the entries in these particular blocks, they are clear, then what you do, you simply click on solve. Now as soon as you click on solve, you can easily see here we are obtaining 3 values for K1, K2 and K3 respectively. Now once these 3 values are obtained, the next steps are very simple. In the next steps we already have these expressions, that is K1 equal to L1 by L2, K2 equal to minus L1 by L4 and K3 equal to L1 square plus L2 square minus L3 square plus L4 square divided by 2 L2 L4. So L1 is provided to us, that is 30 mm. L2 we can basically calculate from this expression. So L2 is nothing, this is L1 by K1. So L1 is 30, that means this cell M26 divided by K1. So what is your K1 cell? K1 cell is the Q8 cell. So here you can put Q8. Similarly, you can calculate for L3, but before calculation of L3, it's better that you go for the calculation of L4. So L4, it is simple, it will be simply minus L1 by K2. So again, this cell, that is M26 divided by K2. So where is your K2? So K2 is basically this cell, that is the R8 cell, right? So you can check out here, this is basically the R column and then basically the 8th row. So it's a R8 cell. Now, once you have that, right, you can actually rewrite this expression to calculate L3, and L3 square, it will simply become L1 square plus L2 square plus L4 square minus 2 L2 L4 K3. Once you substitute all these values here and you simply write down an expression as you can see in the formula bar, right? After that you can obtain the value of L3. So here we have completed the synthesis of a 4-bar mechanism for a function generation problem. Now you can see here that this 4-bar mechanism, it is going to generate a function of the form phi equal to x to the power 1.5. So I hope most of the calculations in this Excel sheet are clear to you, right? So only correction, right, which I mentioned, that you take a positive sign in this Freudenstein equation. With this, I would like to conclude this session. Thank you.